Okay, this is the last question on the combined higher paper. So we've got a picture of a diver. And it says, which two sentences describe the movement of the air particles in the canister? So it's going to be air, so it's a gas. So gas. And we've got two boxes, so make sure we do two. Vibrate fixed position, no, that would be a solid. Move in random directions, yep, that would be a gas. Predictable, nope. Be random. They move at a range of different speeds, yes. Circular paths, absolutely not, it's random. So it's those two, random directions and different speeds. The temperature of the air inside the canister increases. What happens to the movement of the air particles? Well, we should know that when temperature increases, the kinetic energy of the particles increase. The kinetic energy is their speed. So they move faster. All right, and it's more kinetic energy. It could be dangerous if the temperature of the air inside the canister increased by a large amount. Explain, so we need to give a reason why. Explain why. So we need to say something like, so if the temperature increases, so the particles would move faster, so collide with the walls of the container more often, which would increase pressure. So could explode. If they're hitting the walls with enough force, eventually the canister might explode. So 2 marks. We've said that they'll move faster, and the pressure will increase, and we said that they could explode. So that'll be enough for 2 marks. A canister of air was tested to find out how the pressure changed when it was used by a diver. The air was allowed to escape from the canister, and the pressure of the air in the canister was recorded every 5 minutes for 80 minutes. What is atmospheric pressure? Well, if it was allowed to escape, eventually you'll get to a point where the pressure outside is equal to the pressure inside. And we see here, we've got this sort of flatlining area. So what we need to do is we just need to get our ruler and find that flat line and join that up better than I just did. We can try that again. Easier with a ruler rather than the tool I'm using. So that's better. So that will give us a straight line. So we just need to figure out what that value is there. So we just look at our scale. So we've got 1, 2, 3, 4, 5 squares. So 5 squares is equal to 0.5 MPa. So 1 square is equal to 0.1 MPa. So it's 0.1. 0.1 MPa. Divers can safely stay underwater until the pressure of the air canister has reduced by 25% of its original value. Let's find out what the original value was. The original value was there, so that's 1, 2.5 squares, each square being 0.1. So that would be 2.1, 2.2, 2.25, 2.25 MPa. So the original value equals 2.25, just checking, yeah, mega Pascal. So we want to find 25% of that. So what I do is we're going to take 2.25 divided by 100. It's going to give us 1%. Two point two five divided by 100 gives us 1%, which is 0.25, and we're going to do 5 times that by 25 to get 25%. So 0.5625. So we'll do 2 decimal places. 0.56. So when it gets to 0.56, that is when the canister would reduce to 25%. So what time would that be? So we're just going to go back to our graph. We're going to find 0.56. Remember, each of these is 0.1, so that's 0.5, and that would be 0.5, that would be 0.6. So 0.56 would be somewhere about halfway, just over halfway, which is actually hitting that dot there. Bring that down, and that's hitting there. Let's look at our scale on here. So we haven't got one yet. So we've got 1, 2, 3, 4, 5 squares is equal to 10 minutes. So 1 square divided by 5 is equal to 2 minutes. So we've got 22, 24, 26. About 26 minutes. Maybe a little bit more. 26 minutes. That'll be fine. You're normally allowed half a square of error. So I'd say 26. So we can go back to here. And we say that the time is 26 minutes. And the very last part of the very last question, what happens to the volume of air when it is released from the canister? So this is just a question about what happens to gases. And gases, remember, they spread out to fill their container. So the volume of the air would increase. The volume would, it's going in the air. The air is a much, the atmosphere is a much bigger container than the tank, so it's going to spread out. All right, that's it. That is the predictor paper done for Physics Paper 1. Hopefully that was useful for you. Thank you very much for joining me.